Hello everyone, July 31st. Alright, let's deal with this first, and then, well, yesterday was pretty bad, so we're gonna visit this one again. This solution was the official solution, but I don't like it. There was a better one, I think, allowed me to understand this one better, so I'll try that one. Basically just redo it, but I have to do this one first. Alright, let's see, what's this one? Minimum ASCII delete sum for two strings. Given two strings, return the lowest ASCII sum of deleted characters. Lowest ASCII sum of deleted characters, lowercase English letters, to make two string equal. Output 231. Delete s from adds the value of s. Delete t. At the end, both string. Okay. So we'll delete DEE from delete to turn the string delete. Adds to the sum. Delete E. If so, turn both into Leo, we would have. Oof, interesting. DP. Alright, it's gonna be DP, so just need to figure out how to DP this stuff. Okay, so what we have. SEA and the EAT, right? So maybe for this, usually it's gonna be INJ. So we can say DPIJ is the minimum. We can say minimum sum. Okay, minimum sum to get S1 all the way to I and S2 all the way to J to be equal. Right, to be the same. How about this? Right? So we say the minimum sum to get these two. Okay, so what's the edge case? Not really the edge case, so we'll start. Right? So we say if I know Sij, I want to find Sij, right? I want to find Sij. So if we find Sij, if S1 I is equal to S2J, right? If we have these two are the same, that means we don't have to delete them, right? The current one, we don't have to delete them. If you delete is useless. So then we shall return, so if this, then we shall return dp I minus 1 j minus 1, right? Because they're the same. Now what if they're not? What else? They're not the same. Okay, so let's say these two, they're not the same. If they're not the same, then we can delete. Yeah, they're not the same, so we need to delete this one or delete this one, right? So shall be the minimum of dpi minus 1j and dpj, no, dpi j minus 1. So this one will be delete this, right? And then we do this, or delete this, we do this. So it will be this. Okay, now we only need to find the edge case. Edge case, I mean, we'll always delete, so when I is smaller than 0 or j is smaller than 0, right? That's what we want to find out. When that happens, what is, oh yeah, that means one is the empty string and the other we have a letter, so we shall just return. We have to delete this empty, have to delete this, let's say, ORed stuff. Okay, let's give this a shot. All right, def dp I j int. We can say dpij is the minimum. It returns the minimum ASCII sum that makes s1 all the way to I, actually plus 1, and s2 all the way to j equal. Alright, we're gonna cache this. Alright, so we say if I is smaller than 0, return. What if both I and j are smaller than 0? That's a good question. If I is smaller than 0 and j is smaller than 0, now we just return 0. We don't have to delete anything. If I is smaller than 0, then we return ord s2j. If j is smaller than 0, return ord s1i, right? Otherwise, if s1i is equal to s2j, can we put these together? Not really. So if they're the same, no return dpi minus 1, j minus 1. I also return minimum dpi minus 1j and dpi j minus 1. So we'll return dp minus 1 minus 1 minus 2 minus 1. Pretty confident in this one. This is very straightforward, but it's better just to test it first. What the hell? That's not right. I think you forgot to add stuff. Yeah, sorry. You need to add. We're deleting I. And this one you're deleting j. Sorry. Forgot to add. Okay, we are right on one, but we are not right on the other. That is interesting. .303, we lack 100. Seriously, we just did 10. We did the E. We didn't delete the D. How could you not delete the D? Why did we miss one? If I smaller 0, j smaller 0, that is correct, right? If I smaller 0, j is not, then you have to... Ooh, yeah, that's not right. Then you have to delete this plus dp. Yep, we have to delete everything. So dp something plus dj, right? So 0, j minus 1, right? And this shall be dp 0, no, I minus 1, 0. That's not right. How? J is smaller than 0, I is larger than 0, right? So to make them equal, you know what? maybe the easiest way, actually it's not this, it should be to compute the entire thing, because I is smaller than 0, so whatever j, you have to delete everything in j. So maybe this is not this way. We have to delete everything in j, right? We have to delete everything in j. So presum p_sum1 shall equal to list accumulate something. Accumulate. So let's see here, for e in s1 ord e. Okay, we'll change all this into 2. So maybe when this happens, we can do p_sum1 j, and this we can do p_sum2, no, p_sum2 j, p_sum1 I. There you go. That's the right. All right, let's try, some easy test case. Looks solid. Looks solid. Ah, we got a July badge. Nice. Much simpler DP than yesterday. 712. Much simpler DP than yesterday. The only troublesome part is the edge case when I smaller than 0 or j smaller than 0. And to compute them faster, I use prefix sum. Okay, that should be pretty straightforward. Yeah, I tried this and then it's telling me it times out. I don't know why. Yeah, I don't know why. I think I did this and then it just times out. Now it says maximum recursion reached. Oh, I should do I to j minus 1. But it's fine. I think prefix sum is... Yeah, I did that. I did that. Yeah, I don't like bottom up. I think bottom up is always, something I don't like. Because it makes the logic more complicated. If you can do recursion, why not do recursion? Alright, so, we call it solved. We'll go back to yesterday. Alright, so the solution I like is, which guy? Is this guy? No, I don't think it's... which one did I think it's this one. Yeah, I like this one. So... I forgot even to say this. 664. Yeah, probably one of the most difficult DP I have encountered. This is the same solution as the official solution, but implemented via ARU cache. DPLR Okay, dplr is the number of operations, right? Number of prints. Number of prints to fix a sequence of SR of R minus L plus 1 number of SR into the correct SR2, the number of prints to do that. Okay, so that's that. But I don't quite like this way of thinking. So let's turn to solution 2. Okay, so this is solution 1. So solution 2. Alright, so def strange printer self s. So this is inspired by this one. So the ideal is for each letter in S, right? For each letter in S, if we print, right? If we print something, and for each letter we have to, there has to be some print starting from that letter. There might be, right? There might be, not has to be, there might be some print starting from that letter, right? If that is the case, that starting letter will not change once printed, right? Thus, we can say dplr is the number of prints to change R minus L plus 1 number of SL, right? Number of SL into the correct final version, right? So now that we are dealing with dplr, right? There are what we can do is, so we want to paint L to R, right? We want to make L to R the right, and dealing with it, we first print all SL, right? Print all SL. Then we say we print SL. Then one situation, right? Situation is that in order to fix the current sequence, we have to use all the prints in dpl plus 1 to R, right? The other situation is that we go from L to R and find the first letter that is equal to L, right? That's equal to L. Once that is found, we can say we can change only the sequence in between the two SL letters, right? And leave the rest to a further recursion. Okay, so we'll just borrow this entire thing and make some slight changes. Okay, dp is the same, and if this is the same, right, then we will say rest is equal to 1 plus dp l plus 1 to r, right? So this is just, we have to recreate l plus 1 to r from scratch, right? Otherwise, we can say for k in range, we can actually say from L, right? From L to, because we do L to R, right? We can do LL. Actually, LL is this thing. This is actually 1. LL is actually this thing. So we can start from L, right? And then we go for every single time we hit something, then we do it. We hit something, we do it. We hit something, we do it. Until we hit the last one, then we shall do it too, right? We shall do it too. If we hit the last one, because we hold this, and then it'll be plus 1. So you say we don't hit the last one, but I think we should hit the last one. We should hit the last one. So if this is this, and then we say if L is smaller and larger than R, that should return 0. Then we say rest equal to math.inf. We can say L to R. Okay. If SL is equal to SK, right? Then rest equal to minimum rest and what will paint alt SL plus dp something in between is going to be L plus 1 k minus 1, right? Then plus dp, we skip k, so it's k plus 1 all the way to r. Then we'll return res. Yeah, for each other dealing with the first thing on, then we go from, wait, hold a second. Then we go, then we go from this, right, the first letter, and then we, okay, so the answer will just be this. Let's try 2. The first one's not right. Everybody else is correct. The first one is not. It's interesting. Why? 4? You gotta be kidding me. I mean, we should also do the other thing. Actually, SS equal to, for K, this in group by S. Okay. Maybe we do SS will be right. Of course, SS. There we go. All right. Oh, another trick is to remove all the consecutively identical letters, right? Because they can all be printed in one run. So we do SS. But it's interesting, the other one is not right. I think it's just because you have multiple is the same, and then we kind of make it difficult. Yeah, because multiple is the same, so it's hard to figure it out. It's hard to figure it out. Yeah, you find the next one, and then you try to get the thing in between, and the thing in between should be 0. So this is how I understand. Like I think I understand this one better. Oh shoot! To cut this one, Jesus. All right, I want to hold. All right, try it again. Ooh, I think this is not right. I think this is not right. Hold a second. Why is it not right? Where did I got it wrong? I know I did this slightly different than what the other guy did. Maybe that's the reason why this is wrong. Interesting. This one should be 19. Hmm. I mean, he did slightly different. Right? The way he did is this. He'll start from L to K minus 1, and then K plus 1 to R, right? And you start with this. Now I start with L, because that's exactly the same as this thing. Right? It's the same as this thing. So you start with L. If I start with L, I think the difference is in here, every time is equal, we just redo the front. L to K minus 1. Yeah, this also makes sense, right? So because do L to K minus 1, that equals. And some guy says this, some dude says this. And I'm actually following this, like, yeah, that makes sense. But hold on, let's read this one. Why? Where did we go wrong? Ooh, when these are the same. Left index, right index. Oh. This is like slightly different from everything. I use like pivot and stuff. I don't want to pivot. I just want to know why this one's wrong. Okay, so another way to do this is I just follow this. I mean, what you do is it basically says if I start from L, they'll be the same. Then you'll do, so K is L. What if I say, I don't know. Now, why would this be wrong? It doesn't make any sense. No, it does not. Oh. And this makes sense, right? You do one round and then you solve the remaining. It's good. And then starting from the next one, every time you see one is equal, then you say if you have something that's equal, then it's equivalent to solving this thing, right? To solving this thing. And plus, that makes sense. That makes sense. So, yeah, I guess we do have to do it the other way. This way just doesn't work. Yeah, it doesn't work. But why does it not work? Right? You do one round going down and you try to fix from this to the end. Right? You try to fix from this to the end. I don't know. Oh, hold on. When these two are the same, then this is 0, right? Then you have 1 plus... That is right. And then you keep going to find something, okay? So in this, I do solve LK minus 1. In this, I solve. So basically, is this. What's the difference between this and this? So you're saying these two actually not the same. From L to K minus 1. From L to K minus 1. And I say it's equal to, from, you print that first. And then you solve this part. That's actually not right because so I do have to use this. Maybe not. L to K. What if L and K are the same? If L and K are the same, then this will be 0. Yeah, that's not right. Oh, so nah. So yeah, we just need to do this. And this shall be 1 plus dp L plus 1 R. Right, and then plus 1, if they're equal, then from the start. Oh. Yeah. Okay, so now we are dealing with there are two scenarios, right? Two scenarios. There are two scenarios. First, we print SL, right? Then handle the remaining dp L plus 1 to R from scratch. Second, we go through L to R and find SK. We go through L plus 1 to find SK is equal to SL. Okay? When that happens, the amount of prints to make L to K, right? To make L to K correct is equivalent to dp L K minus 1, right? Because when we do dp L K minus 1, we print SL all the way k minus 1. We might as well extend that by one more position, and all the changes and all the other changes needed in dpl k minus 1 can be identically applied to making SL to k plus 1 work. Right? Yeah. So this is scenario 1, right? Once SL to k plus 1 are done, we deal with sk plus 1 to L using dp k plus 1 r. It's not L, it's this one's r. So this is the first scenario, right? First scenario. And this is second scenario. For all SSL is equal to SSK. Yeah, the other way is not right because we're dictating 1 plus this is equal to dpl to k minus 1. But that's not necessarily true. That's not necessarily true. We necessarily probably don't even print this first, right? It could be, yeah, because like you basically do this in one scenario, which is just this, right? And it could be some other scenarios, so you didn't consider the other scenarios here. Tough. I even do a rerun, we still have an issue with this one. And it's much, much faster. Yeah, I'll put this into the... Hey, this is not a nightmare. It's supposed to be a nightmare, man. Yep, this was a nightmare. Okay, we call this one. I wonder if I can see if I'll remember this if I have to deal with this one more time. Most likely not. This is so freaking difficult. Alright, let's try this one. Call functions with custom context. Enhance all functions to have the... Oh, JavaScript. Now skip. JavaScript. Minimum string length after removing substring. You are given a string S consisting only of uppercase. You can apply some operations to this string, where in one operation you can remove any occurrence of one of the substring AB or CD. Return the minimum possible length of the resulting string that you can obtain. The string concatenates after removing could produce new AB and CD. So we have AB, so remove F, C, A, CD, remove AB, remove, so it should be FC. Right? A, C, nothing. Alright, so this is a stack. We can basically just go for it. 96. Letter in S, if, actually no, we should say while stack and S is letter stack minus 1 is equal to A and letter is equal to B, or stack minus 1 equal to C C and the letter is equal to D. Let's make it more explicit. While this stack.pop and actually it's not while, because once you pop you have to get the next one, so I think it should be if, then we pop. Alright, and then else say stack.append letter, because otherwise we can say A B A B, right? If it's A B, then we get a B A B pop, and that's it. We should not while, we should not keep popping. We have no more to pop. So we do this, and then we'll return length of stack at the end. Is this one right? Looks solid, but let's test with A or A B. That's a good one to test. Looks solid. Let's go for it. Okay. Use stack as similar to parentheses, right? Use stack. Okay, what's the next one? Oh, another easy one. Okay. Lexicographically smallest palindrome. Yeah, given a string S, lowercase English letters, and you're allowed to perform operation on it. In one option, you can replace a character in S with another lowercase English letter. Your task is to make S a palindrome with the minimum number of operations possible. If there are multiple palindromes that can be made using the minimum number, make the lexicographically smallest one. A string A is it's just talking about what lexicographically return the resulting palindrome string. So we want to perform operation. You can replace, so the length doesn't change. So what you want to replace in S to another one. So let's say in this one, because you want to make a palindrome, right? We want to make a palindrome, so we will check the front and end. So we change this to the smaller one, to F, right? A, B, C, D. So A will change this, B will change this. So we try to change the small, right? We change the small. So, and then we also want to the minimum number of operations. So we just go from outside in, right? Outside, and then we'll change the letter with a smaller ASCII value, and that shall do. Yeah, we change the smallest possible. So something like this. Something like this. We will start from, say I, j equal to 0, len s minus 1. Okay. We can say list s equal to list s. Okay. While I is smaller than j, if list I is not equal to list j, list I shall equal to list j equal to minimum list si list sj. Turn dot join list s. What do you think? What I think is I forgot to do I plus equal 1, j minus equal 1. Sounds like. Yep. 2 pointers and change the letter, change the corresponding letters to the smaller one. Okay, let's hit one more. What's this? Find the punishment number of an integer. Given a positive integer n, return the punishment number of n. Punishment is defined as the sum of the squares of all integers I, such that this, the decimal representation of this can be partitioned into contiguous substrings such that the sum of the integer values of this equals I. Is defined as the sum of the squares of all integers from 1 to n. The decimal representation of this can be partitioned into contiguous substrings such that the sum of the integer values of these substrings equals I. Punishment number n is defined as the sum of the squares of all integers in between such that it's between 1 and n, and the decimal representation of I squared can be partitioned into contiguous substrings such that the sum of the integer values of these equals I. What the hell? That's possible? 3 integers I satisfy the condition, so we have 1. 1 times 1 is 1. 9 times 9, oh my god. 10. Oh my god. Oh my god, really? Holy crap. I never know. Like, man, the number theory is very difficult and very interesting. 10 you can do, 36 you can do. I mean, we might as well just find all of them. Alright, we might as well just find all of them. Because n is to 1000, so just from 1 to 1000, we just need to figure out what numbers can be partitioned. What the hell? I mean, 1000, if you square this, right? And we want to partition in a certain way so that I can make it equal to 1000, and of course we can do it. But if we given anything, like 36 squared, 1296, how do you partition this? Right? How do you partition this? I mean, we can say 1, and we want to partition this to make it equal to 35. Ooh, maybe we can DP this, right? We make so basically this is just gonna be DP what? DP the string 296 and 35, right? We have a value, then we have 35. Is it true or false? Right? Is it true or false? Or DP, 96 with 35 minus 12, 23. Or that's it. So we do these two, and then we just keep going through, right? We keep going through, and then the answer is yes, 1296 can be 35. So we have to do this. So we have to go find everything from 1 to 1000. We find everybody, right? We find everybody. So we need to find everybody. That means we'll have a list of, 1 is something, but I think so 1 is yeah, we just need to find a list of all the all the values, right? It's like 1, 9, 36, 10, 36, whatnot. So we get all of them, and when we get a value, we binary search, and then we find the sum. So I will do this way. I'll do this something like this. Hold on. Because we can pre-compute. So we will definitely pre-compute this. I think pre-computing shall be the, so we'll def initiate. Nah, we don't have to. Or do we need to initiate? Yes, we need to initiate. We do nothing, right? So self dot, what's this? Self dot, self dot. Now it self dot variables. Okay. So we'll do def underscore pre-compute, right? Pre-compute. We're gonna return a list of integers, and this one will have def dp will be the representation, right? Num string and target. Is this possible? We dp this from tools, import cache, and we can cache this, right? We can cache this thing, and then we just want to find number this is possible, target is possible. Then we just say if int this is equal to target, return true. Otherwise, for I in range all the way to, not to the end, because we already handled it to the end. So it should be len num_str -1. Okay. If dp num_str I to the end. Well, we'll take I, so I plus 1 to the end. And no, we're gonna say left shall equal to I plus 1, right? Left is this. Oh, I can actually say if target is smaller than 0, return false. If target is equal to 0, return true. Otherwise, we'll go to len nums. Okay, and we say dp, basically this, and because this can be empty string, right? And then we say if not num string, but we still have something, then that will be return false, right? That's a false. Num smaller than 0, yeah, that's a false. And this is equal to 0. Actually, this will not happen. Yeah, let's make sure this won't happen. So if this is 0, or this is not, why would this happen? Why the not string will happen? This shouldn't happen, right? It shouldn't happen. it will happen. Like if I is 0, right? If I is 0, then the left basically, yeah, I cannot be 0. I cannot be 0. So it always, yeah, I just left cannot be 0. So we have to. So it's this one shall not happen. So this one should be fine. And we will always go from 1 to the end. 1, right? We have to take, not really. We do go from 0. We do go from 0. So the left is going to be just plus 1. Exactly. So we'll take at least 1, right? And we'll take 2, take 3, take 4, take the entire thing, right? Take the entire thing. So left is this. And we're going to do this and target minus then we can say if left is larger than target, then we'll break, right? It's no, if it's larger, then we just return false. Now we just break. At the outside we say return false, right? And then we say if this is the target minus left, if it's true, then we'll return true. If it's false, we keep searching, and then we shall say for I in range from 1 to 1001, if dp stri target is also I. If it's true, then we'll do I. So I'm going to return this thing. So variables equal to self dot precompute and self dot presum psum equal to list accumulate self dot variables. So it tools, I'm going to do accumulate. So now we have these n. So we need a binary search. You know what? It's a most 1000. Binary search might not be actually. So we can say index should equal to we do need binary search though. Okay, from bisect import bisect. Let's do bisect right. Okay, so index equal to bisect right self dot variables and so if it's equal, then we'll always go to the next one. So we'll always be index minus 1, right? Index minus 1. So if it's index minus 1, what if you are small? Now you cannot be small. Index minus 1. So we shall return self dot psum index minus 1. Let's give this a shot. So 10 shall be 182. 37 shall be 1478. No. For v in this, v squared. So this is n. What's this? Punish number n. Very bad. That's fine. We can see what's the variables, right? Print self dot variables. That is bonkers. Ugh. That is bonkers, man. Doesn't make any sense. So this is wrong. How is 2 correct? 2 is 4. Oh, it's square. Damn it. Right, 1, 9, 10, 37. 37. Can 37 be done like that? What's 37 squared? 37 squared. 1369. How can you do 1369? I mean, you can't. This thing is not right. Let's see. If target equal to 0, yes. Oh, target equal to 0 and used up num. If target equals 0 and not nums, yeah. There we go. That's the problem. So we have all these. It's on you. That's interesting. That's slow. It's very slow. Pre-compute all the oh, because I have a print. My bad. Let's try it again. Pre-compute all the viable values for computing the punishment number. Right. The viable values can be calculated via DP. Okay. I shouldn't print. Probably that's how to make it slow. I'll try it again. Do we get any faster? Well, it just gets slightly faster, so make me wonder. Maybe there's a better way to do this, right? Hold on, let's try another one. Progressively compute. How about that? Progressively compute. So pre-compute. Can we progressively, like, give it a value, I'll compute. And give me a new value, I'll compute. That don't seem to be. Actually, I don't know. Let's see. Any faster method? What are the hints? That's the same idea. Maybe we don't even need to DP this thing. Maybe we don't need to use it in the cache. Maybe they changed it. Like, actually, let's try. Maybe they changed it. That's possible. What I'm saying is we don't do that. We just say get variables. Okay? And we'll get an n. Should be smaller than that. Then we still dp, but we say we're all the way to n. So we can say variables equal to self dot get variables n, and index can return sum for I in range to index variables I squared. Okay, is this one faster? Oh, just don't compute the whole thing every single time. Ah, shoot. Should be this. This is wrong. Alright. Yeah, let's do the DP. I don't know, like, what if you don't do DP? What if it's not DP? Without DP. Without cache. Do we run faster? It's about the same. It's about the same, so nothing. Okay, I think that's it. We hit 1 hour mark. Okay, I will see you guys tomorrow.